What's going on, guys? Today we have a very special video planned. Today we're going to be going over how to orchestrate vibe coding agents and make vibe coding work for you. So the tools that are coming out today, the tools like Cursor or Gemini or Claude Code, any other CLI tools that are extremely powerful. Some of the issues with them is that they lack direction and accountability. It's very easy to vibe code, but it brings a lot of issues for our programmer that we didn't necessarily see prior. And so the issues that I have seen with vibe coding is that the models can hallucinate or produce a lot of errors. Essentially, we lack a way to control the errors. Your prompt doesn't give the model enough context at your project up front before it starts building. So essentially, your poor instruction making is essentially the reason that your vibe coding agents are not working. And three, you probably don't know when to step in. The human feedback loop is still important. So then what's the solution, right? The solution is we're going to design a prompt that forces the model to write unit test or wait for human approval to make sure that we're setting those gates for human evaluation. Be mindful of context limits for models and when needing to provide relevant documentation. This one should be a no-brainer. Utilize multiple LLMs to handle different aspects of the development cycle, i.e. reasoning models for the plan creation and coding models for the engineering tasks. This part is extremely, extremely important. Not all models are built equally, so I really recommend looking at some of the coding benchmarks and kind of thinking about the tasks you're trying to accomplish. And four, obviously, be prepared to step in if and when the model needs help. So before we look at the prompt, let's just look at the general architecture of what we're trying to build here. So we, as the orchestrator, work with the mastermind engineer to set up our code base to define clear and isolated tasks for our worker agents to complete. So our workers interact in isolation on task and escalate issues back up the chain. So we have this nice up and down or circular flow that describes our general architecture. So this is our general architecture, so let's see kind of how we're going to structure the prompt to accomplish this. So here's our prompt example. So it reads, I'm building a product name with a purpose and tech stack X for Y and A for B. This is essentially describing your scope, and being as descriptive as possible here is extremely important. We're essentially going to ask it to create a system architecture. So we're essentially going to format this file in Markdown, say the file folder structure, what each file and module does, where state lives, and include any assumption that you're making. Save this as architecture.md and return it. Over here, I just have a quick example of kind of what this would look like. So here you can see the file shoulder architecture, the module description, description of some of the services, and you get the point. As we jump down, we're going to next prompt a second task or a second prompt and say, the task plan. Using the architecture above, write a step-by-step plan to build the MVP. Each task must be extremely small. One concern, less than 15 lines of code, be testable in isolation. Extremely, extremely important here. Have a clear start to end, avoid ambiguity, and we just give the model an example, essentially, to say this is an example of a task that is easily completable. And we're going to save this as task.md and return it. One thing to note here is that you can design this task plan to be for one engineer or a team. In our architecture here, we're obviously working with a team of engineers, but this can be designed for one engineer. And if you're going to do that, just make sure that you're doing it in a multi-step. So you're essentially going to make a one-step plan and then ask the model to break it out into engineering roles that you define. So here's an example of that where you can kind of just see the process ID where it gets a little bit more complex, where we define process IDs for our agents to go in, the task, which they would end up being initialized or committed to GitHub, and the result of the test. As we jump down, we're essentially going to now be going into the agents, the agent prompt. So as we look at the agent, we're essentially going to be giving them coding instructions on how they should operate within this code base and given the architecture and task list that our master orchestrator has given. So you are a front-end engineer tasked with building this code base, read architecture.md and task.md. Carefully follow the tasks with prefix. This is where I was mentioning that you can add prefix to make it a little bit simpler for your models, your agents to follow. Complete one task at a time. After each task, stop, prevent a minimal test rip, and run if applicable. Wait for confirmation before proceeding. And confirmed, commit with message, feat, scope, summary, task. Essentially just a commit style, and finish mark with @task.md style with done. So it's essentially going to go back and update this task.md file for the orchestrator to find out. One important detail that I found in this is it's important for your agents to know what system that you're running on, so don't overlook your system specs. So you can just ask ChatGPT to run a script that will give you, some of this information that would be helpful for an agent to know about your system. And I just pass this along with this prompt as well. This is also the coding protocol, so this essentially just tells it how you want the coding updates to be made. So minimal code per task, don't make unrelated edits, so no sweeping edits. Don't break existing functionality, make code precise, modular, and testable, and if any human intervention is required, give API keys or tell me clearly. So what does this really mean for you as the programmer? So here you can see the old system where we have one project manager and we have a team of 3 specialty engineers working in tandem. They're obviously connecting through services, shared services, but everybody is reporting up to this project manager who's essentially going to be leading this team. In this architecture, we are limited by human capital, and we have a distributed knowledge and ownership, where this guy knows about the front end, this guy knows about the back end. Let's say this guy knows about the infrastructure, okay? The cloud services, right? There's distributed ownership of each of these services and distributed knowledge of these services, okay? As we switch down to our agentic system, here's our new system. Now we have multiple project managers, and we have role-specific agents that are able to be created and deleted on instances. So our new observations here are obviously that we're limited by compute resources and not human capital anymore. The top of the pyramid widens as the value creation eases. As this guy, as we go back to our other system, as this guy gets the ability to create code and create value easier, he actually ends up in the old system getting promoted to project manager. In our new system, this project manager, the same guy, now just gets tasked a team of engineers to create even more value, so more project managers can join him at the top of the pyramid. So our value creation, pyramid widens as value creation eases as it flows down. And the total ownership of the project scope completely changes. Now this project manager is in charge of the entire project scope, meaning he is in charge of this front-end engineer, the back-end engineer, and let's say our cloud services engineer. And if you're thinking, where does this leave our old project manager? Well, let's just not talk about him. To wrap this video up, if you're like me and you're thinking, what's next? I actually asked ChatGPT to make a comic for what happens after, and yeah, I'm keeping my eye on my air fryer.